Okay, thank you. Thanks for all. So मेरो साउन्डमा ग्लिच भयो भनेदेखि चाहिँ इन्टरप्ट गर्नु है। सो मैले यहाँबाट केही पनि देखिरहेको छैन सुन्दापट्टिको। सो अगेन थ्याङ्क यू अल फर जोइनिङ। यो चाहिँ एकदम नयाँ एक्सपिरियन्स भइरहेछ अनलाइनबाट अफलाइन, नत्र मोस्टली अनलाइन भइरहेको। तर एनिवे थ्याङ्क्स फर अटेन्डिङ अनि थ्याङ्क्स टु अर्गनाइजर्स फर अर्गनाइजिङ यो वन्डरफुल इभेन्ट। यो पालि त एकदम नै मिस भयो। मेबी नेक्स्ट टाइम when I back to Kathmandu, we few weeks-मा आइसकेपछि maybe we organize a different meetup पनि। Okay, so again, thank you all for both attending and organizing. So lots of effort लगाउनु भएको छ अर्गनाइजरहरूले। So really appreciate that. अनि so सबै अटेन्डीहरूलाई पनि so last time पनि त्यही नै भन्थेँ म। So if you want to help for organizing this kind of event, just ping and let the organizer know, because there are lots of things going on in the background. Okay, so let's dive into that. So first of all, so this is the thread post from the Google for Devs because we are on vacation, right? So if we check the threads, Google for Devs, or maybe take out a photo and we'll explore like what does this mean at the end of this talk. Wishing all developers out there a bug-free and joy-filled holiday season, and may your code be ... and your time with family and friends be cheerful. Okay, so if you are busy, then I think we are done. So we'll be talking about like a scope भित्र नै यसकै भित्र पार्टमा डिप डाइभ गर्छौँ हामीले चाहिँ। सो फर्स्टमा एज अ डेभअप्सको कुरा गर्दाखेरि चाहिँ मोस्टली धेरै अर्गनाइजेसनहरूमा अथवा धेरैले फलो गर्नेमा चाहिँ सो वी जस्ट ट्राई टु रिलिज, अनि लास्टमा चाहिँ सेक्युरिटीको पर्सपेक्टिभ चाहिँ ओके अब एभ्रिथिङ इज सेटअप, अब इम्प्रुभ गर्ने भन्दाखेरि चाहिँ सो लेट्स डाइभ इन्टु सेक्युरिटी भन्दै गइन्छ भने सो दिस इज अ न्यू सेट अफ प्रिन्सिपल DevSecOps, सो सेक इन बिट्विन, त्यही भएर सो सबै कुराको बिचमा चाहिँ सेक्युरिटीको पार्ट पनि आउनु पर्यो भन्ने हो। सो फर्स्टमा चाहिँ this is the like current security landscape. So we are going to like maybe we go to Agile or something, अनि त्यसपछि कहिले डेलिभर गर्ने सफ्टवेयर होइन, कति फास्ट डेलिभर गर्ने, एक हप्ता दुई हप्तामा अथवा सर्टेन टाइममा रिलिज गरिहाल्ने, विच हेल्प्स द बिजनेस अल्सो। अनि त्यसपछि चाहिँ बिस्तारै सेक्युरिटीको पार्टमा आउने भन्दै कम्प्रोमाइज हुँदै गइसकेको हुन्छ होइन। सो वी जस्ट मेक अ वर्क अराउन्ड टु पास द सेक्युरिटी, or maybe not upgrading the security part of the side of the world, अनि which makes our code already vulnerable, अनि त्यसपछि पछि आएर फिक्स गर्नलाई we just keep it as a technical debt, अनि फेरि different time, effort, त्यसपछि security flaw also, and if something goes wrong, then like that very much hampers the business as well. So यो पार्टको लागि चाहिँ so let's see from the past also, you know. So this doesn't need to be a very big thing. So I think like we all know about the log4j vulnerability, which was just like I think 1 year or 2 years before. So like just a single kind of a thing which affected like I think that this is the one of the biggest vulnerability discovered so far. र यसले चाहिँ लगभग एक दिनको बिचमा नै इट अफेक्टेड लट्स अफ युआरएल्स, लट्स अफ एप्लिकेसन्सहरू। सो even a single line of the code, or maybe a single library, could make the whole world vulnerable. So this is not a thing to be less considered. And like some of these examples, you can see like other big examples as well. So यसमा चाहिँ so how do we pass the software supply chain? So we just write the code, we push to Git maybe, and we just build the code. That could be Docker or jar file or whatever artifact, and we deploy. And there are like lots of dependencies in between. So there are lots of links or chain in this supply chain, and each of these links are vulnerable. So we should be so we're talking about how do we remediate, or how do we take care of each of these red lines in the supply chain? So for that, so there is a word called shift left. So that means like from the beginning of writing the code, or maybe like even before writing the code. So planning phase button is so we just consider security or testing, and that will also be like general testing as well. So all of these things should be from the starting, not from the beginning. So we are just starting like shifting left towards a plan code build. So if somebody says we do it at the right, then that will come maybe after the monitor or maybe after the release. But if we shift left, then we just consider the security things to be taken care of from the starting of the software delivery pipeline. So this is the like important phrase which we'll see if you just search for DevSecOps भनेर सर्च गऱ्यो भने पनि, so this shift left comes up in the top. Okay, so while talking about the security aspect, so these are the major two things. So securing the code and securing the infrastructure which we run. Like infrastructure means all of those that could be maybe even Docker, Kubernetes, AWS, Google, Azure, like whatever, and code including the libraries, dependencies, and those things. So the first part is securing the code. So we call it a SAST. So this is conducted just before building the code. That would happen even on the developer machine, even before sending the code to Git or somewhere. Uh, so here we just apply some of the libraries or maybe some of those vulnerability scanning things. We just check our code if it is vulnerable, and if there are other dependencies which are vulnerable. So the topic we are realizing from the local machine-बाट नै कसरी secure गर्ने भन्ने चाहिँ, so that's the concept of SAST we see. So त्यसको लागि चाहिँ scanning the code त भइहाल्यो, तर एउटा major पार्टमा चाहिँ let's say like even we see like एकदम युजफुल अर सबैले दिने एक्जाम्पल नोड मोड्युल्स हेऱ्यो भने त्यसमा कति धेरै प्याकेज हुन्छ नि एउटा तान्यो भने. सो त्यसको डिपेन्डेन्सिजहरू चाहिँ, सो देयर इज अ साइट कल्ड devs.dev. So this is from the Google as well. So if we see, and we can see like other dependencies त्यो लाइब्रेरीले के युज गरिरहेछ त फर npm go maven यो सबैको लागि चाहिँ. So let's just say like maybe express सबभन्दा सजिलो npm को. So we can see like, so Expressly saying, okay, Express doesn't have any kind of dependencies, right? Or any kind of like other dependents. So if we search for maybe, I don't know what, just search for something Google protobuf, okay. So dependency, okay, it doesn't have any dependencies. So let's see like any of those dependencies which are within these packages. So we can just explore, and if there is any kind of the vulnerabilities as well, so it will show up to that part. So this will be a useful site to look on, and it is almost like updated things as well. Okay, so next thing is how do we scan those codes through those SaaS tools? So there are lots of SaaS tools. So if you go to this last link, so I'll be sharing the slide, so don't worry about the links. So if we see for the source code analysis tools, there are lots of tools which are dependent on specific language, and I think there should be, because Java को code scan गर्नको लागि PHP or एकदम generic खालको use गरेर पनि हुँदैन हैन. So that should be supporting the language we're writing the code, and that just doesn't include scanning the code or scanning the specific language. That also includes scanning if there is any kind of the hard-coded credentials. So often like we just commit maybe AWS keys or Google Cloud Code token, or maybe even passwords, anything like that, right? So if we scan those kind of a hard-coded credential in the early phase, maybe even just sending to, let's say, GitHub, right? So if it is open source, then one single commit will be a history there. So त्यसको लागि चाहिँ there is a tool called Talisman भन्ने, GitHub ThoughtWorks Talisman. So it just scans all of the code and locates or if there is any kind of the secrets or tokens or things like that, apart from like त्यो स्पेसिफिक ल्याङ्ग्वेजको स्क्यान गर्ने पार्ट त भइहाल्यो, तर सेक्रेट स्क्यानिङको लागि पनि. सो आई हेभ दिस वान स्मल एक्जाम्पल, सो द्याट्स वाइ आई सेयर द होल स्क्रिन. So I have this one small Git repository. So this is called the damn vulnerable web app. सो मैले चाहिँ एकदम सजिलो ड्याम भल्नरेबल वेब एप भन्ने बित्तिकै एकदम भल्नरेबलवाला वेब एपको एक्जाम्पल लिएँ होइन. सो यु क्यान जस्ट सी दिस रेपो or maybe just go through the original fork as well. So if I scan to this repo through the talisman, so this is my code. Okay, so if I do talisman, scan with HTML and it just shows the HTML report. Okay, so if I spin up one of this small server and if I go to localhost 8000 and a summary, then it shows like what are the file like contains and all of those things, and it shows like each of these file will show what are the vulnerabilities or what are the passwords or things like that. So if you go to like maybe config inc, so this has this password like written in plain text, right? So that's where we can see like every summary of each of those files, and to सबै फाइलहरूमा भएको if there is any kind of those passwords or secrets or any things like that, maybe just caught the password word as well. So this is a very important tool that will help for scanning those credentials as well, and also for the misconfiguration of our cloud infrastructures part. So I'm talking about so this is a Kyveron. This is a Kubernetes manifest configuration checker. So I mean, like these security scanning code is not only for the code, like the general major logic wala code, but also for those security scanning and also for the configuration we use to apply inside the cluster or maybe inside the cloud as well. So if we go to playground.kyverno.io, so this is the policy we apply. This is the type of the policy we keep on, and if we check whether this resource is within this policy or not. So if you just take start and it'll just say like failed. Okay, so this file doesn't apply or doesn't follow our policy. So that's why like this is how we can check the policy enforcement or policy apply भएको छ कि छैन, अथवा even like we can just block anything which doesn't follow our policy, right? So this will prevent just even before applying those changes into our system. And this could be integrated into any of those IDE plugins or maybe even the Git commits. So if we talk about scanning the files to the talisman, if we configure those Git commit or maybe like even pre-commit hook, then commit गर्नुभन्दा अगाडि नै okay, it will just scan all of those files, and if it is secret, it will not allow us to commit. So these are the things we can do with these SaaS tools. So the next part is those build. So after we write the code, commit to GitHub, and there comes a part for securing, for creating those builds. That could be like jar file, Docker image, which has a lots of these layers. So if we see for example of the Docker build, so there are lots of layers. So there could be a base image, we could be adding libraries, we could be adding files, we could be using already pre-baked images, and we could be writing those files which are already writable, or what are the permissions that is available for the file. So these are like lots of things which comes in the build layers. So that means like the vector of the security risk increases after starting to build the project. So for त्यसको लागि चाहिँ how do we secure the build? So one of the important part is securing the build environment, right? So that means what is the access the build environment has? Like, does the build environment need to be able to access like the external resources, or even maybe just internal componentsहरू मात्रै युज गरेर build गर्न सक्छ त? अथवा if we already have maybe let's say the base image which is already in our system and it doesn't need to even access the internet, so that could be a secure, but maybe that doesn't work in every of the cases. And अर्को चाहिँ what is the access the build environment has? Does it have access to maybe something destructive, does it have access to changing some configuration, तर त्यो configuration change गर्ने कुनै पनि कुराहरू चाहिँ build systemमा नचाहिन पनि सक्छ हैन. So त्यो कुराहरूमा चाहिँ so in terms of network and identity as well, so if we take care of those build system accesses, then that will help us prevent those kind of vulnerabilities or getting unnecessary things into our system. So one of the thing is like this least privilege. So what is the specific things that the build environment needs to have? If we can have only that specific privilege, not more, then that will make us in a good place. And the next thing is, how do we pass the secrets to the build environment? So we already checked, we could not pass any of those secrets or tokens into the Git, nothing, no more. And so let's say, for example, if we need to pull some private libraries, right, that we need to authenticate. So how do we pass those tokens or secrets which authenticates with those private library or repositories? So that should go through a system like we just encrypt those secrets or tokens and place it on maybe a key management system or somewhere, and just pass a reference of that to the build environment, so that like even by mistake we will not be passing any of those build specific credential for the intermediate build part, and maybe that will just go live. And also the monitoring and logging system of the secure build environment, so that we just see if there is any kind of the anomaly in the build system, maybe like it is reaching other unnecessary networks during the build, or maybe it's consuming more of the resources which are not required. So, and another like one interesting concept within this build environment is there is a thing called binary authorization. So this means, so let's say for example हामीले चाहिँ Docker image build गर्ने केसलाई consider गर्यो भनेदेखि चाहिँ, so if the Docker image is built, then the Docker image is attested by the build environment, right? And we can configure like, okay, so only that kind of the image which is attested by our build environment or signed by our build environment will only run into our Kubernetes cluster. So if somebody try to run untrusted images or non-attested images, so our cluster will reject it on a single site. So this could also be a one good capability of the build environment. So this is a simple example of a Google Cloud platform. So where we say like under the binary authorization, this comes as a feature, and there are already open source software as well, which could be installed into our cluster, and we just checks the images is signed by our certificate or not. So this is a simple example and already available feature. So it says like only allow the images which have been approved by the following attester. So the attester means the build environment, right? So only the same Docker image which is attested by the build environment can run into our cluster. Okay, so we have the build completed. So we have to store the artifact which is generated from the build environment somewhere, right? So here's the thing. So if the artifact storage or the place where we store those Docker images is not secure, then त्यो अघि त्यत्रो secure गरेको काम नै आएन हैन. So for that we just need to apply those fine-grained access control. So that means, for example, if our cluster needs to pull the access, pull the Docker images from our artifactory, then only the cluster should have the access to pull the image. So हामीलाई चाहिँ क्लस्टरबाट पुश गर्ने एक्सेस चाहिएन हैन. जस्ट बिल्ड इन्भाइरोमेन्टलाई पुश गर्ने एक्सेस चाहियो भने पुल गर्ने एक्सेस चाहिँ आवर जस्ट क्लस्टर निड्स इट हैन. So त्यस्तै, so if there is any kind of a secured Docker images, let's say if we have something, let's say private service, let's say a transaction service which त्यसलाई चाहिँ हामी छुट्टै एउटा कुनै क्लस्टरमा डिप्लोय गरिरहेछौँ भने, so maybe the general cluster should not have access to pull that specific Docker image or pull that specific code. So यस्तै कुराहरू चाहिँ if we apply those fine-grained access control, then we'll just be relieved that only the only the access which is required for us is there. And also the end-to-end encryption, so within from the build environment to the artifact storage, and also from the artifact storage or the registry to the cluster, or where we actually run the Docker image. And also clean the dangling image. So this means like if the Docker image or any of those artifacts are old enough, so let's say if we are running some image on Ubuntu 16.04 and maybe that has the vulnerability, so long term अहिले 3-4 वर्षसम्म बिल्ड नगरेको प्रोजेक्ट चाहिँ if we just try to build, maybe त्यसमा अझ एरर आइहाल्छ होला अथवा त्यो एरर रिमिडिएट गर्नै गाह्रो होला. So if we just periodically update the image with those security patches, then it becomes just easier. And the next thing is the Docker image scan. So already भइसकेको Docker imageहरुमा पनि there could be issues. So for that there is a library called Tribhuvan. Okay, so there is a library called Tribhuvan which just scans those Docker images. अनि त्यसमा कुनै vulnerability छ अथवा inside libraryमा कुनै vulnerable छ भने, so it will just show us. So the next part is the cloud security, where we deploy all of our services, right? So here we just need to be proactive, just like we are doing from the source to the build time as well, because when we go to cloud, everything is API, and just one attack could just reciprocate to multiple services. So there is a like the interesting example. So if if there is some compromise of the keys or maybe a single container or something like that, so attacker could just do something and maybe just add a new user or things like that, or maybe call a different kind of API and run crypto. So like the attack vector just increases while we are using a public cloud. So just considering a case of a Kubernetes cluster vector attack vector. So there are like lots of pieces. This black one is the attack vector. So one could be an access API server, because we're on the API world and lots of those infrastructure things are already running within the APIs and accessible through the APIs. So one vector is the API. There could be a misconfigured Kubernetes dashboard. The image could be one, right? And also maybe the misconfigured daemons which are running inside the nodes, or even the person which has access to use the cluster could be a vulnerable, or maybe even the application could be vulnerable, or maybe some vulnerability could come through load balancer or things like that. So these are like lots of vulnerabilities which comes to any system, but we are just talking about the Kubernetes for now. So you सबै vulnerabilityहरूलाई चाहिँ there could be like let's just consider the Kubernetes cluster. So त्यसमा चाहिँ के कुराहरू चाहिँ vulnerable हुन सक्छ भनेर थाहा पाउने त हैन. So there is a thing called CIS benchmark. So your benchmark चाहिँ there are lots of companies that are involved in making this. So you benchmark lesson, they show us like, okay, so these are the things you need to take care. So the API should not be publicly accessible. The containers should not be maybe someone shouldn't be able to access the container or things like that. So त्यो सबै बेन्चमार्कको लिस्टहरू चाहिँ so they provide, and by following those principles our cluster could be a secure. So त्यसको लागि चाहिँ, so if you just go to cissecurity.org, so there is an extensive list of these benchmarks. यो सबै software even environmentहरूको लागि चाहिँ, so there are lots of those benchmarks. It is checklist नै पाउँछ. त्यो चेकलिस्टको आधारमा चाहिँ we can just run those benchmark things. So त्यसको लागि चाहिँ it is a bit easier also. So if we use the second one, Kubebench, so Kubebenchबाट चाहिँ सिधै like CIS benchmark applicable छ कि छैन भनेर we can just check in a simple one. I think ढिला भएको जस्तो लाग्यो. So let me just run it quickly. So to benchmark saying, so we can also see like if the benchmark is passed, fail, or maybe it's non-applicable, or if you can see through the dashboard whether we are inside the CIS benchmark. So to CIS जस्तै there could be other benchmark as well, maybe PCI हुन सक्छ, which just depends on what type of system we are running on. So the gist is doing all of these things inside the code and taking the culture of the security as a core from the beginning. So we are not talking about like doing everything manually or things like that. So we just need to document all of those things as a code and do it from the beginning. So okay, so just the final part, the deployment time. So what are the things that needs to be considered for at the deployment time, right? So the user could be coming on and we'll just be going through the load balancer and to our backend services. So even before the load balancer, we just use the backend security policy. There is the feature called Cloud Armor. There could be like all the open source software as well. It just protects like if there is any kind of the calls from unknown APIs or maybe the some blacklisted IPs or whatever request ideas are अथवा we just apply those WAF principles which are already available in our system, or maybe those WAF rules which are well known to be applied to any kind of the system. So यो कुराहरूलाई कन्सिडर गरेर र यो कुराहरूलाई चाहिँ मोनिटर गर्ने सिस्टम सेटअप गर्न सकियो भने from the beginning, so we don't have to talk about security only at the end. So what is the policy is violated? So we just need to use like if this is after low priority, maybe like CIS benchmark company, there's a warn, maybe there are different level of those alerts, right? So this could also be like inform if there is a bit of severe, then alert, and if there is any kind of like high vulnerability, then we just stop. Okay, so yeah, that's it for now. So we are on a vacation mode. Happy Christmas, Happy New Year. And if there's any question, I think that I'm already running out of time. But if there's any kind of the questions or things like that, so just reach me out to this name. So I'm on the same name everywhere. So लास्टमा चाहिँ त्यो अघिको फर्स्टमा च्याट जिपिटीले चाहिँ च्याट जिपिटीमा सोधेको थिएँ मैले. So what does this mean by Google for devs ko कुरा 000111, or maybe like you can just also search for this last one. Okay, thank you, thanks a lot, and bye.